In this question, we've got a mass of 3 kilograms. It's on a rough plane, and it's being pulled up that plane by a tension force. We've got the coefficient of friction, we've got information about the forces, and we're asked to find the acceleration as it moves up the plane. So the fundamental thing to do here, the most important thing to do, is draw a clear force diagram. I appreciate you can't use colour in the exam, but even with a black pen and a pencil and a ruler, you should still be able to get a very clear diagram to organise your thoughts. Once you have that diagram, we're going to be writing down 3 equations here. We're going to need to resolve perpendicular to the plane, we're going to resolve parallel to the plane, and we're going to write down a friction law. Okay, those are going to be our 3 equations, and then we just solve them. So let's start perpendicular to the plane. We've got r directly. We've got a component of 25, and that's 25 sine 30. And we've got a component of weight, and that'll be 3g cosine 20. And those forces will all balance to equal 0 because we're not accelerating off the plane. When we look parallel to the plane, we've got the other component of 25. So we've got 25 cosine 30. We've got f going against us, that's minus f. And we've got the other component of the weight force, which is 3g sine 20, also going against us. Now we are accelerating in this direction, so we've got the resultant force equals ma, the mass is 3, and the acceleration a is what we're trying to find. And finally, the friction law. Because we are moving, we know that F equals mu r, so F equals 0.3 r. If we weren't moving, that would be an inequality, F less than or equal to mu r. But here we go, we've got 1, 2, 3 equations, and already we've got most of the marks for this question. We just need to solve them. And if I look at those, I can rearrange the first equation to get r equals. Just rearrange that, and on the calculator you get r equals roughly 15.127. Substitute that into number 3, and you get a value for friction. That'll be 4.538. Notice how we try and keep quite a few significant figures here. And finally, if we substitute that value for f into equation 2, we can rearrange to get the acceleration, and you should check that you get 2.35. Okay, maximum of 3 significant figures here. You could also give just 2 significant figures and leave your answer as 2.4. But that is the acceleration of the box. Okay. Part B suggests one improvement to the model that makes it more realistic. The easiest answer here is probably to include air resistance. Okay, that's the worst habit in the world. I've got them right there. Don't write on the questions in your exam, but your answer should be just to include air resistance. Other valid answers are to include the physical size of that box, because maybe it'll start to topple over if we pull with too great a tension. Okay, plot twist. The rope now breaks. Okay, this is a big change to the situation. If the rope breaks, there is no longer a tension force. So all the forces theoretically can change. Show that after the box comes to rest, it immediately starts to move down the plane. So we're going to need to look at a new situation. So we've got a new force diagram where really I should even redraw this, but for now I'm just going to cross that tension force out just to exaggerate, to really emphasize that it is no longer there. There's going to be another change. When it comes to rest, friction will actually be pointing in the other direction. So we also need to cross out friction and draw it going up the slope now. Because whether it actually moves or not, the box will be trying to move down the slope, so friction will be going against it. So make the decision here, will it actually move or not? We need to make a comparison between F and the component of the 3g force down the slope. So we need to do our equations again quickly. We need to work out the new reaction, and that's going to come from r minus 3g cos 20 equals 0. Okay, that's going to give us an r value of approximately, I don't know, 3g cos 20 we can get on the calculator. And then we can calculate friction. We can calculate the maximum friction available. which will be mu r, so 0.3 times the value from that equation above. And then we want to compare that with the component of 3g down the slope, which is 3g sine 20. So we need to get values for these things. If you put these into your calculator, you should get a max friction of 8.3 approximately, and a component of the weight should be approximately 10. And we can see that the 10 is greater than the 8.3, therefore the box will accelerate down the slope. Make sure your conclusion is there, so you've actually answered the question. Okay, so the force acting down the slope is greater than the maximum possible friction available, which would try and oppose it.